Hello everyone, today we will talk about slope aspect, contours and hillshade in surface analysis. Uh, First I'm going to give you some basic information about the tools. Let's start with slope. The slope represents the variations of the landscape. You may want to find the areas at risk of landslide based on the angle of steepness in an area. It means that you can find areas where soil erosion occurs. Slope can be in two units. One of them is degree, and you may represent the unit in person as well. And there is a relationship between the two units. It depends on the angle. If the angle or degree is 45 degrees, it means that in percent you can see it in 100%. And here is some calculations. And to calculate slope in ArcMap, first of all we need to have our water shed area. It should be in DM, and we should go to spatial analysis toolbar. By expanding it, we should go to surface toolset, and after opening it we should go to slope tool, and by double clicking as an input raster we should insert our DM data, and we can rename and show the save folder here, and we can select one of the units here, and I want to select percent, and you can press OK. So here is output dataset. Here in red color we can see steeper locations where soil erosion is highly set to occur, and the next tool we want to do is aspect. And considering aspect, it identifies the downslope direction of the maximum rate of change in value from each cell to its neighbors. It's 8 neighbors. In fact, aspect in other words can be thought of as a slope direction. So here we can see a circle where the aspect can be in a range of 0 to 360 circling, and here we can see red in 0 north facing and east in yellow color, and kind of white color here which shows 180 degrees, and west can be described in blue color. And to calculate aspect we should go to surface toolset and opening aspect tool. Again, as the input raster we should insert our DM data, and we can rename and show the save folder, and we should click OK. And there are some reasons why we use aspect tool. Aspect can be used to identify locations which are north facing, that enables us to find areas for ski runs, and also we can see solar illumination to identify the diversity of life. We can also find southerly locations where the snow is likely to melt first, that residential locations might be hit initially. And we also able to find some land areas where the slope is flat, plain, that enable us to find a spatial land for landing a plane or helicopter. So here is our output dataset. We can see here different directions of the slope of the DM, and here in flat color, in this color, kind of gray color, we can see plain flat place here for landing a plane or helicopter, and these areas in red color can be suitable for ski runs and so on. And the next thing I'm going to talk about is contours. Contours are lines that connect locations of equal value in a raster dataset that represent this continuous phenomena such as elevation, temperature, precipitation, pollution, or atmospheric pressure. And the areas where the contours are closer together indicate the steeper locations. They correspond with the areas of higher elevation, and the output can be described in white and black color, and in white color on the output elevation dataset we can see higher elevation. To do that, we should go to contour tool. Here, as in input raster, we should insert our DM data, and contour interval depends on you. For example, for me, I'm going to insert 300, and base contour, according to my DM data, the lowest value is 860. That's why I'm going to put it here. And if your Z factor is clear, you can also insert this value, and we should press OK. So here, where the contour lines are closer, we can conclude that these areas are steeper. Steeper locations can be found here, and these areas are realized to be considered to be planar, more flat areas. The next tool I would like to give some basic information is Hillshade. Hillshade tool obtains a hypothetical illumination of a surface by determining illumination values for each cell in a raster dataset. It can greatly enhance the visualization of a surface for analysis or graphical display, especially when using transparency. And here we can see two terms. For example, azimuth. The azimuth is the angular direction of the sun, measured from north in clockwise degrees from 0 to 360. An azimuth of 90 degrees is east. It shows east side. The default azimuth is 315 degrees, which means northwest. And the next term is altitude. The altitude is the slope or angle of the illumination source above the horizon. The units are in degrees from 0 to 90. The default is 45 degrees. To calculate Hillshade, we should go to Hillshade. As an input raster, we should insert our DM data, and here we can see default values for azimuth and altitude, and we should click OK. Here's our output dataset of Hillshade, and by going to properties function of the dataset, we can change the transparency from 0 to 100 to display it more suitably.